Hi students, moving into chapter 7, we are looking at integration by parts, which is basically the chain rule backwards. So let's say we look at the chain rule, which is sitting right here. This is my typical chain rule, and let's see where this came from. So for my chain rule, I could say that this u of x, v of x equals the integral of that stuff right there, and I'll write that down. Okay, I have that written down. Now what I'm going to do is I'm going to break this up into two separate integrals, and I'm going to bring this part of the integral over to the other side. Okay, so I just did that manipulation. I have this guy is sitting on the side all by himself, and we basically, well, I got this guy all by himself, so I moved that guy over here, messing around with positives and negatives anyway. And then after that, this right here is just dv. So the integral of u dv equals this stuff right here, which is just uv minus v du, which is what this says right here. So we've gotten this. Now what we've got to do is see how this is going to work. So we're going to work an example. Now you're going to have to pick the u and you're going to have to pick the dv. That's a tricky part. Sometimes you'll pick the wrong u or the wrong dv, in which case you have to go back to the drawing board and try again. So if what you're doing ends up in a total mess, just stop and think, well, maybe I chose the wrong u and the wrong dv. So I'm going to let u in this case equal x, and I'm going to let dv equal e dx. Now I need to know what both u is, and I need to know what du is, so and I need to know what v is. So oops, I forgot my e to the x. So what I'm going to do is take the integral of both sides so I can figure out what v is. So if I take the integral of both sides here, v is going to equal the integral of this is just e to the x. Okay, and I'm going to take the derivative of this one so that I can figure out what du is. Du equals, take the derivative of both sides, is dx. So next I'll change pen colors. You're going to want to keep this separate because you're going to use these things. So now I'm going to say integral of u dv is going to equal, and notice the integral of u would be the integral of x, and then dv is this x dx, so that would have been what's sitting there, which is what I wanted. It's going to equal u times v, so I go get u, that's an x, v is e to the x, minus the integral of v, that is e to the x, and then du, which is dx. And then I'm just going to solve that, which is pretty straightforward. Alright, so I have that one written down. Now if you were to take the derivative of this, you should get, and you will get, if you did everything correctly, you should get what's sitting right here. And sometimes you might want to do that, especially when taking a test or something, just to make sure that you've got it right. Now very similar to the last one, I've got to pick my u and I have to pick my dv. So I'm going to pick my u to be x. That way du equals dx, and that's pretty sweet. Then I have to pick dv. I'm going to choose dv to be the other part of this, and you'll have to take the whole thing in its entirety. It's, you know, part of it has to be u and part of it has to be dv. Then I'll take the integral of both sides and say that v equals, and the derivative of, the integral of this would be negative cosine x. So now I know what v is. And now I'm just going to plug back into my formula here, my integration by parts, and you'll have to have that, you'll eventually have that memorized, but just checking to make sure it's u, which is my x, dv I said was sine x dx. I make sure that's what I started with. It is, so I'm good. Then I'm going to say that it is u times v, so that is minus x cosine x minus the integral of v, which is negative cosine x, and then du, which is dx. Alright, I think I can integrate that pretty quick. Alright, indeed I did, and if once again, if I take the derivative of this, what I'm going to end up with is that's sitting right there. Notice this would be, you would have to use the chain rule here, and your terms would combine, and that's how that ends up that way. It's pretty cute, isn't it? All right, we get to try again. Let's pick our, just looking at this A part here, and then the B part is just an expansion of that. I'm going to choose for my u, I'm going to choose x squared, then I'd get du equals 2x dx. Next I'll choose dv to be equal to e to the x dx. I'm going to integrate both sides so that I can get the v, and I just get the v equals e to the x. So I'll start here. Oops, I'm going to change pen color. Okay. X squared e to the x dx equals, and I need u times v, that's x squared e to the x minus the integral of v, which is e to the x, times du, and du in this case is 2x dx. Well, I still really can't integrate that, but I did that example 1, I think it was, and this will integrate pretty quickly. I just will have to take that 2 again. What I'll need to do is just do integration by parts again, in which case I'm going to pop that 2 out front and just let u equal x, du is going to equal dx, dv is going to equal e to the x dx, and v is going to be e to the x, and then I'm going to throw that into the equation and change pen color. Alright, I just rewrote all of this out again, and the only thing I'm really doing is I'm just doing this thing right here. The rest of this is already rolling like it needs to be. So I'm going to have minus 2x e to the x, and then this is going to be plus 2, and then just an e to the x plus c. So if you'll note on this, if it's an x to the n, what you're going to have to do is you will have to do integration by parts n number of times. Notice how when it was just an x e to the x, we did integration by parts once. If I were to have x squared, I had to do integration by parts twice. And in this one, it'll be very similar. It's just you're going to get, let's try it down here. We'll just write x to the n e to the x dx is going to be whatever that x to the n e to the x minus, and then you're going to have this integral of, and then it's going to be e to the x, and then there'll be an n here, and then the x will be to the n minus 1, whatever that is, dx, and you'll just have to keep doing that over and over again. Alright, notice it's saying repeated use of integration by parts. This happens, and you just need to practice with them so that you can see that it will indeed happen. For this one, I'm going to choose my u to be e to the 2x in this case, and then that means that du equals 2e to the 2x dx. Seems kind of sticky, but we're going to do it anyway. I'm going to let dv equal the sine x dx. That means that v is minus cosine x. Alright, I'm going to substitute that in. Alright, at this point you're tempted to go, well, that's still very messy. But yeah, just keep on these ones with the e's and the sines, or e's and a cosine. Just stick with it, because there's going to be a little trick we're getting ready to pull out of our hats here. I'm going to do integration by parts again. I'm going to pull that 2 out front, and I'm going to let u equal to the e to the 2x, and I'm going to let dv equal to the cosine x. Okay, so I just rewrote it and then picked my u and v and then did my little dv stuff. Okay, so now it's 2 times, and it's just u times v. So that's e to the 2x sine x minus integral of, and then it's v du. And you might look at it and go, hey, wait a minute, you really didn't do anything, but, oh, I forgot my little dx here, sorry. E2x dx, but if you'll notice, this thing right here matches that thing right there. So I'm going to pull a little algebra trick. Let me simplify this and then I'm going to do it. Okay, so now I've got it all written down, and notice that I can take this thing right here, because these two are what we would call like terms. There's one of them over here, minus 4 of them over here, so I'm going to pull this over to the other side and now have 5 of these integral of e to the 2x sine x dx equals, and then I'm going to write those down. Alright, so I have it all written down, and that's all good and well, but I only want to know what one of those equals because they just asked me about one, so I'll just divide this by 5, divide both sides by 5, and I'll write that down. Alright, so there would be my answer to that, my next problem. Next we're going to go into definite integrals. Oops, go ahead and get that. In this next problem, not only are we going to do definite integrals, we're also going to figure out what the integral of natural log is. And we can do that with integration by parts. So if I say that u is equal to the natural log of x, then du equals 1 over x dx. If I let dv equal to dx, then I know that v is just equal to x. Okay, so I'm going to plug that into my formula here. Alright, so let's watch this very last part where I say it's v, which is x, times my du, which is 1 over x dx. And this is pretty crafty here because that's going to be pretty cute. This is going to be plugging this in, 2 natural log of 2 minus 1 natural log of 1. Of course, that's going to be gone. Minus, and that's just an x evaluated from 2 to 1, and I'll write the rest of that down. Alright, there you have it. There's your exact answer. You can plug that in your calculator if you want to. So of course now we get to use integration by parts in our solids of revolution. Okay, so I've got a natural log function. I'm going to revolve it about the x-axis. I plan on using the disk method. The disk method would then be volume is equal to, they want me to go from A to the x-axis, which would be there at 1, from whatever A is to 1. And then it's pi times my function squared. My function happens to be the natural log of x, quantity squared, dx. So on this I'm going to have to do integration by parts, so let's give this a try. Now this pi is going to go out front. Of course, he's just a constant, so let me let u equal to the natural log of x, quantity squared. du in this case, I'll need to use the chain rule. Chain rule says take the derivative of the outside, that's 2, leave the inside alone, natural log of x now to the first, times the derivative of the inside. The derivative of natural log of x is 1 over x, so I'll just write this as over x dx. Then I'll have that dv equals dx and v equals x. And for my volume then, that's going to be u times v, so that is natural log of x, quantity squared, times v, which is x evaluated from a to 1, minus the integral of v, which is x, times du, which is 2 natural log x over x dx. Notice how lovely it is that these things cancel. So let me put in my a and 1 here. Those two will cancel, and then I'll just be able to use this integral that I found last time. Alright, just using my formula and plugging this in, and yes, I forgot my pi, but I put it back in. And then I'm just going to simplify this a little bit, put in my a and my 1 and see what I get. Alright, I put all that in, but it didn't simplify to anything pretty, and this is what I get. Alright, stunning. Now, as always, if you have any question, be sure to email me, and you can see me at the Collaborates. Thank you very much.